So in this session, I will explain you the program for the third experiment. Program for third experiment, that is add two 16-bit numbers. So how we can write assembly language program or machine language program for adding two 16-bit numbers by using 8085 microprocessor. Okay, so for this one, it is a program for 8085 microprocessor. This is generally the program for third experiment. So now here given add two 16-bit numbers. So we two 16-bit numbers. So this one 1A and 1A 1B, that is the first number. Okay, this is the first 16-bit number. So 1A 1B. So this number it is in hexadecimal, and 2A 2B, that is also in hexadecimal. So we know that this one you can say digit in hexadecimal is if converted in binary form, then in that case will give 4 bits. For example, if it is 1, so this 1 in hexadecimal can be written as 0001. Okay, A can be written as A means 10, so that it is 1010. Okay. Yes. So this one. So how many bits? 4 and 4 8. Okay. And then in the same way 1 and B. So this one again can be written as 0001, and this B can be written as 1011. Okay. It means total 16 bits. Total 16 bits. So that's why here 1A 1B, that is a 16-bit number, and in the same way we can say 2A 2B, it is also 16-bit number. So this one it is the program first in hexadecimal. So LSB, since microprocessor, that is 8085, it processes only 8 bits at a time because it is 8-bit microprocessor. So here you can see at 2000 address we have LSB of the first number we entered. So this one, the first column, that is the address. So these all are addresses in RAM. So first, and one memory location can store only 8 bits at a time. So here 1B, it is of 8 bits. So that 1 bit will take one memory location, and this 1A will also take 8 bit, and this 1B also will take 8 bit, means one memory location. One memory location here is of 8 bits. So here this one it will take one memory location, this another 1A it will take one memory location. So for storing 16-bit numbers, we need two memory locations. So that's why 2000 and 2001. So these two addresses in RAM, we need these two addresses for storing one 16-bit number, and here another two memory locations we are using to store another 16-bit number. So you can see here, so LSB, in the form of LSB, MSB, we are storing. So first we stored the LSB in 2000, and then MSB of the first number in 2001. And in the same way here at 2002 we stored 2B, and then at 2003 we stored MSB of the second number, that is 2A. And result we will get at memory address 2004 and 2005. So why at these two addresses? Because this is 16-bit addition, so the result will also be of 16 bits. So 16-bit result meaning 16-bit cannot be stored at one memory location, because one memory location it is of only 8 bits. Okay, so that's why to store 16-bit result we need two memory location, and again we are we can say dividing two parts. We are dividing the number into two parts, LSB and MSB. We are saving LSB at 2004 and MSB at 2005. Okay, so that it was so now these all are the addresses for the numbers and results. So now from here the programmer starts. The first instruction which is used for this one, it is LHLD. So written LHLD to 000. So what this instruction LHLD does, what it does. So LHLD is the instruction to load HL pair with the content of 200, and after whatever the address it is, means this address and the next address content. Okay, the content of 2000 and 2001. Okay, it means the content of this one and this one. These two are going to save in HL pair. Okay, so these two. So I can say right here, these two are going to save in HL pair. Okay, so HL pair, since H is one register and L is another register, so these registers are again of 8 bits. So when we make pair, then we get 16 bits. Okay, so here we can write here HL pair, we can save 1A, 1B. So 1A, 1B with saved in HL pair. 1A, 1B be saved in HL pair of register. Then after next instruction given, exchange. So XCHG, that is exchange. So this instruction exchange the content of HL pair with DE register. So whatever we have in HL pair, that is going to exchange with DE. So whatever we have, so that it will go to DE. Okay. So now we have in DE register 1A, 1B. That's what we get here. So by using this instruction. Then after next instruction, that is LHLD 002. By using this instruction, so LHLD the same one. So whatever we used to the first instruction, same it is. So now here we are loading HL pair with the content of 2002, and after this 2002 whatever address it is, so that, so 2002 and 2003, so contain, so whatever data we have in these two memory locations, so these two data will be saved in HL pair register. So that it will go to HL pair, and then here we have 2A and 2B. Okay. So now we got in HL pair this one and in DE this one. Okay. Then after written DAD D. So this instruction adds. So now earlier, means in addition of two numbers, we used instructions just like add ADD. So that it was using the accumulator to save the result. But here, since this one it is the result, it is of 16 bits and the accumulator is of only 8 bits. So the result cannot be saved in the accumulator. So that's why we here this instruction it is used. This instruction add these two 16-bit numbers and the result is going to save in HL pair register. Okay. So when this instruction is executed, then now we get in HL pair. In HL pair it will become so here it is given B and here B. So B here it is of if you convert in decimal, that is 11, and here it is 11. So 11, 11, 22, and if you divide that by 16, divide by 16. So here it is 22, and then if you divide this 22 divided by 16, so 16, then you will get 6 here, and so 6 you can write down here, and then after 1, whatever here you have in the percent, that it will become as carry, that is the carry, so that it will go to the next one. So 1 plus 2, 1 plus 2, and 1 carry here it was, so 2, 1 and 3, 2, 1, 3 and 4, so 4, 6 here we got, and then after A, so A, so we have A is 10 and here it is 10, 10, 10, 20 in decimal. If you divide that by 16, so dividing by 16 to convert the decimal into hexadecimal. So 20, if you here it is 20, then in this case it will become remainder it will be 4, and the percent will be only 1. So that remainder means here you will get 4, and the 1% it will go here. So 2 plus 1, and the 1 whatever it is here percent, that it acts as carry. So 2 plus 1 3, and 3 plus 1 4. So result you will get this one. Okay. So now this 4 6 that is that here it is 4 6. So that is the LSB. So LSB, and this one is MSB. Okay. So we will get in HL pair this 4 4 4 6 in HL pair register. Then next instruction, that is SHLD 2004. This instruction, it is to store HL pair at memory address 2004 and 2005. Okay, so whatever we write down, so this instruction is to store the number at this two addresses. It takes two addresses. For example, if you write down 2004, so it will take 2004 and 2005, and if you write here 2005, then it will take 2005 and 2000. Means two consecutive memory locations will be used for storing the result. Okay. So that's why if here it is, so it means what you will get at 2004, you will get LSB, that is, sorry, at 2004 we have LSB, so that is 4 6 you will get, and at 2005, so you will get 4. So that's what you will get. Okay. And then the last instruction, that is RST5, that is start 5, that it is kind of this instruction was executed sends the processor to process which is the subroutine call. So it sends to location 0028. Okay. So by using this instruction, we can make sure that the processor is not going to execute the next instruction after this memory location. Okay. Or you can say holding the processor to further execute any instruction, okay, which is saved in memory location. Because instruction, it is nothing but a kind of data saved at different memory locations, and when those data are or you can say processed by the processor, then we say that okay, that instruction, it is being executed. So this is how we can write assembly language program to add two 16-bit numbers for 8085 microprocessor. And so this one is assembly language programming. Now if we use corresponding hex codes to program, then that it will be called as machine language program. So in case of machine language program, so we have to write down corresponding hex codes. For example, here for LHLD. For LHLD we have code 2A. What we have code, or so I think we should use other color. So 2A, that is for LHLD. And for this address, memory address, we have to write 0020, because I already explained earlier also that we write down the address in reverse, or you can say we write down LSB first, then after we write down MSB for address. Okay, so that's why the LSB of this address I have written first, then after MSB of this one I have written. Then the next one, it is XCSG. For this instruction we have a hex code, that is EB. For again LHLD, for the same hex code we have to use, that is 2A, and this time it is 2002 now. So that's why we can write down first of all this one LSB, so 02, then after 20. Then after next instruction, that is dash D. So for this one we have a hex code, that is 19, that is 19. And for SHLD, the hex code here, it is SHLDs, yes, that is SHLD. For this we have 22. Okay, for SHLD we have 22, and then after whatever address given, for this one we can write down. Now again for LSB first we write, then after we write down MSB. So LSB, this one 04, so 04, then after MSB 20. Okay, and for RST5 we have hex code, that is EF. You can use another instruction, that is HLT also, hot. Okay, so here I have used RST5. So if you use these hex codes, so hex codes are machine codes, okay, because how processor understand this one. For example, if it is 2A, so 2A, it is nothing but this 2A we can write down 2A, it is 0010, and